Hi, today I'm going to build an enterprise network in Proxmox. I'm going to create several VLANs. I'm going to have a DMZ VLAN, a guests VM, a servers VLAN. I'm going to segment and separate them, and I'm going to route through them using nftables. You can see here that I have my VMBR0 that is attached to my NIC0 and it has access to the outside internet. I'm going to need a VMBR1 that's going to be my inside trunk. You can see here that I have my VMBR0 that is connected to my NIC0 and it has access to the outside internet. I'm going to create a VMBR1 that is going to be the switch of my NFT machine that is going to act as an 802.1q trunk. A trunk is a network link that carries traffic for multiple VLANs over a single physical cable. So on data center home, I'm going to go to network and I'm going to create a Linux bridge. I'm going to call it VMBR1. It has to be VLAN aware, and I'm not going to give it an IP, a gateway, anything. Just create it and apply configuration. All done. I'm going to create my first container. That's going to be my NFT container. I'm going to call it NFT for nftables. Give it a password. Next. It's going to be an Ubuntu container. 8 gigabytes sounds good. Next. On ETH0, I'm just going to grab an IP from my DHCP server, but you can give it a static IP. That's okay. Now, I can see my NFT container right here. I'm going to click on it. I'm going to go to network, and I'm going to add another interface. That's going to be my VMBR1. I'm going to call it ETH1, and that's it. Good. Now I'm going to create my first container that's going to be on VLAN 10. Instead of doing it through ClickUps, I'm going to go to Home, Shell, and I'm going to paste those lines. They're going to create a container that's going to be named VLAN 10. It's going to be on bridge VMBR1 with tag 10, meaning that it's going to be on VLAN 10, and I'm statically giving it an IP and a gateway. Good, I created it, and you can see it here. Now I'm going to create my VLAN 20 container. It's going to be on VMBR1 tag 20. Its IP, it's going to be 192.168.20.10, and its gateway, it's going to be .20.1. Oh, good. Now I have an NFT container, a VLAN 10, and a VLAN 20 container. I'm going to go into my NFT container, and I'm going to get its console to configure it so it's the trunk in between the VLANs. I'm going to log in. First, I'm going to verify my interfaces. Cool. I have my ETH0 and my ETH1. I'm going to update my machine and install VLAN support. Good. Now I'm going to create my VLAN 10 on ETH1.10. And I'm going to bring it up. And I'm going to assign its gateway. Now I'm going to do exactly the same for VLAN 20. Bring it up. And assign its gateway. Now if I check my interfaces again, I see that I have ETH1.10 and ETH1.20. Those are my VLANs, and I see that I configured their IPs correctly. Now I'm going to start my other machines. My VLAN 20 is up, my VLAN 10 is up. Let me check their routes. And I can see that it's routing through 192.168.10.1. That's the ETH1.10 on my router. And I can see that this machine has the IP of 192.168.10.10. And on my VLAN 20 machine, I can see that I'm routing through 192.168.20.1. That's the ETH1.20 on my router machine. And I can see that this machine has the IP of .20.10. Good. Now from my NFT machine, I should be able to ping both of them. 10 works. 20 works. Great. So NFT container can talk to VLAN 10 container and with VLAN 20. But later on, if I want VLAN 20 to be able to communicate with VLAN 10 through the NFT container, I need to enable IP forwarding on the NFT container. Okay, so what have we achieved? I have in here in the middle my NFT machine. It has an interface ETH0 pointing to the internet and another interface ETH1, that's my LAN interface. And it's divided into 192.168.20.1, that's on my VLAN 20, and it's connected to my machine 192.168.20.10. And I have another leg on VLAN 10. I have 192.168.10.1. That's ETH1.10, just like we configured. And I have my machine 192.168.10.10 on this VLAN. Now, I want my NFT machine to be both a router and a firewall in between my VLANs. I want it to filter packages and I want it to route packages. And I'm going to do this with nftables. Okay, so I have my NFT machine and I have my VLAN 10 machine on VLAN 10 and VLAN 20 machine on VLAN 20. Now I'm going to transfer my NFT machine into a router and a firewall with nftables. I'm going to update my container and install nftables. Now I'm going to enable and start it. Now let me open the configuration file. Let's go through it real quick. Flush rule set is going to flush the previous rules and it's going to apply the new ones. I have one table, it's called inet filter. Inet is going to deal with IPv4 and IPv6 and it's going to filter traffic. And inside I have three chains. Chain input is going to deal with traffic coming into this specific machine, into the NFT, into my router, my firewall. The chain forward is going to deal with traffic that is passing through my NFT container. So for example, from VLAN 10 to VLAN 20 through my router, it's going to be dealt by this chain, and the chain output is going to deal with traffic that's coming out from this container. First, I want to concentrate on the forward chain because I want to create rules that are going to segment VLAN 10 and VLAN 20. I want to create rules that are going to allow them to communicate on certain ports and block all of the other ports. On my forward chain, I have added this line, policy drop. It means that unless I have explicitly allowed traffic to a certain port from a certain destination to another destination, I'm going to drop this traffic. This means that for now, since I don't have any allowing rule, everything is blocked in between the VLANs. The line city state established, related accept means that traffic that was already initiated and has been established is allowed. For example, if I send a SYN request, so the SYN ACK coming back is going to be allowed. And now I'm going to add my first firewall rule. IP SADDR, that means the source address, 192.168.10.10, IP DADDR, the destination address, 192.168.10.10, ICMP type echo request accept. What does that mean? That simply means that this machine can ping this machine. This traffic is going to be accepted. I'm going to apply the rules. So I brought up my VMs. I have VLAN 10 and VLAN 20. From VLAN 10, I'm going to ping 192.168.20.10, and it works as expected. But from my VLAN 10, if I ping 192.168.10.10, nothing happens. The traffic gets dropped. I have two nftables, and I remind you the chain forward is dealing with traffic in between the VLANs. I'm going to add another rule. As you could see from before, the machine 192.168.20.10, when it tried to ping 192.168.10.10, nothing happens. Why? Because the chain forward is going to evaluate all of the rules top to bottom. And if it doesn't find anything that matches what is going on, then it's going to drop the traffic. And traffic drop doesn't return any response. But for debugging purposes or on internal networks for any reason, you might want to reject instead of drop. And let's see what happens. Reload the table. My machines, and as you remember, this ping didn't return anything, but right now, it returns a message, port unreachable. I still had 100% packet loss, but this time I know what's going on. No, you may need it for debugging purposes or whatever. You maybe going to need it to test internal network or something, but now we know the difference between drop and reject. Reject is going to return a reject message, and drop is going to be silent. So as I showed you, you can use the forward chain to segment your networks, and you might want to put, let's say, IoT devices like cameras or something inside VLAN 10 and not give them internet access, and then have a guest network on VLAN 20 that is not going to have access to your IoT devices on VLAN 10. You can simply do that by adding rules that are going to reject or drop access from VLAN 20 to 10 or VLAN 10 to 20. And we have talked about traffic in between the VLANs. Let's say that on VLAN 10, you're going to have a camera, and on VLAN 20, your guests are going to connect to, and you don't want them to have access to your cameras, so you're going to block them. But one thing that we have not touched is that none of the VLANs have internet. They cannot ping Google. They cannot go outside. How can we give internet access to the VLANs? So back to my diagram. This machine, 192.168.10.10, when it pings 192.168.20.10, it knows that it's not inside this VLAN. So it goes to the default gateway and it asks who is 192.168.20.10. And the gateway said, I know who it is, it's this guy, and then it can forward the traffic to here. But now if I ping 8.8.8.8, it's gonna come here and this guy is gonna say, hey, it's also not in this network, so I'm gonna go this way to the internet. But the problem is that it's gonna come with this source IP address, 192.168.10.10. So I need this interface to masquerade its IP address so that when it reaches the internet, it's going to reach the internet with the IP address of ETH0. So it's not automatically dropped by the internet. Because when this IP reaches to the internet just says, yeah, this is an internal IP. I'm not going to deal with it. I need an external IP. So how are we going to do that? Back to my nftables, the first thing that I have to add inside my table inet filter inside chain forward, I have to add this rule saying that traffic originating from VLAN 10 and going to ETH0, meaning the internet, is going to be accepted. So traffic coming from VLAN 10 going to the internet is accepted. Now I'm going to scroll to the bottom of my page and I have to add another table, the table IPNet with the chain post routing. And in this table, I'm going to add the rule that IP with the source address of my VLAN 10 and the destination of my ETH0, meaning the internet, is going to be masqueraded. This is going to solve the problem of the internal versus external IP that I said. Traffic coming from VLAN 10 and going to the internet is going to be masqueraded. It's going to receive the IP of my ETH0 interface and it's going to be able to come back. Let's see how it goes. Bringing back both of my machines, VLAN 20 cannot ping the internet, but VLAN 10 can. I have 100% packet loss here and 0% packet loss in this VM. And that's how you can segment your VLANs so that one VLAN is going to have internet to the outside internet and another VLAN is not going to have access to the internet. So far I talked about routing traffic, but now I'm going to talk a little bit about security. On my input chain, meaning traffic that's incoming into this specific machine, the NFT machine, I'm going to add this rule. That means that traffic coming from ETH0 with destination on port 22, meaning trying to SSH into my router VM, I'm going to add a meter. I'm going to add a limit of 2 concurrent connections. Whenever I try to establish more than 2 connections, I'm going to drop it. Let's see how it works. So on my Mac, I'm going to try to establish an SSH connection into my NFT machine. Once, twice, and a third time. And now it just hangs. The machine drops the traffic. It's not going to accept it because of my rule.